Now the next question is the last question from the test 2, that is question number 5, and also the question number 10 from the playlist. Write algorithm for Newton interpolation del. The A part of the question is algorithm construct a different table by eliminating data set to ensure that the interpolation point is at beginning interval. So the algorithm is step 1, start the program. Step 2, read n. Step 3, for I equal to 0 to n minus 1, read xy and yi at 0 and I. Step 4, calculate forward difference table for j equal to 1 to n minus 1, for I equal to 0 to n minus I minus j. Y at ij is equal to yi plus 1 and j minus 1 minus y of I and j minus 1 and I and j. Step 5, print forward difference table for I equal to 0 to n minus 1, for j equal to 0 to n minus I minus j. Print y at ij and j, next line, and I. Step 6, read a point of intersection. Step 7, assign h is equals to x of 1 minus x of 0 and assign u is equals to a minus x 0 by h. Assign sum is equals to y 0 of 0 and p is equals to 1. Step 10, for j equal to 1 to n minus 1, p is equals to p into u minus j plus 1 by j. Sum is equals to sum plus p into y0 at j and j. Step 11, display a and sum. Step 12, stop. The B part of the question is obtain first, second and third derivative from Newton formula. Step 1 is start. Step 2, read number of data. Step 3, read data from x and y. For I equal to 0 to n minus 1, read xy and yi and 0. Next I. Step 4, read calculation point where derivative is required, that is xp. Step 5, set variable flag to 0. Step 6, check whether given point is valid data point or not. If it's valid point, then get its position at variable index for I equal to 0 to n minus 1. If xp minus xi is less than 0.0001, index is equals to I, flag is equals to 1. Break from loop and if, next I. Step 7, if calculation point xp is not in x minus 1 data, then terminate the process if flag is equal to 0. Print invalid section. Step 8, generate forward difference table for I equal to 1 to n minus 1, for j equal to 0 to n minus 1 minus I. Y at ij is equals to yj plus 1 comma 1 I minus 1 minus y at I comma j minus 1. Next I and next j. Step 9, calculate finite difference h is equals to x1 minus x0. Step 10, set sum 0 and sign is equal to 1. Step 11, calculate sum of different terms in formula to find derivative using Newton's forward difference formula. For I equal to 1 to n minus 1 minus index, term is equals to y index comma I into I. Sum is equals to sum plus sign into term. Sign is equals to minus sign. Next I. Step 12. Divide sum by finite difference h. To get result, first derivative is equals to sum by h. Step 13. Display value of first derivative. Step 14. Use some procedure to calculate further derivative. Step 15. Stop. Thank you.